class, it's Mr. C with your Saxon math for the day. Today we're looking at lesson 96, and this all has to do with function. Functions is something that we haven't talked about yet, and so today we're going to look at a rule for a function, find a missing number in a function table, make a table for a function, and then graph a function. Now, in math, we don't use the word function very often. Typically, when you hear the word function, you think of something on a calculator, that you hit a button and it creates a function. This is something that you'll do a lot more as you go into algebra and geometry. But a function is really rather simple. It's simply using one number to solve for another number. So let's look at this table. We know a surface area of a rectangular prism is the sum of the area of its sides. So if we look at a cube, for example, it has 6 sides. We've got the front, the back, the top, the bottom, and the 2 sides. Yeah, that's 6. All right, and that's always going to be the case. So in every cube, it's going to be 6 times whatever the surface area is of the square, right? So it will always be the same. So we can look if the area of a square is 4, so that would have been a side of 2 times 2, right? That gives us a surface area of 4 centimeters squared. Well, in a cube, we would just multiply that by 6 and get 24. Now, if the area was 9, because each side was 3 centimeters, then it would be 9 times 6, which is 54. If it was 16, it'd be 16 times 6, which is 96, and 25 times 6 is 150. That's a rule. It will always be that way. But showing it on a table helps us to think, oh yeah, something times 6 is whatever else. And so we could extend that out and put any number we want on this side of the table, simply multiply it by 6. And we'll get that. Now, what we're doing here is we're using a function. So in this case, S equals surface area, A equals area. No, that's not right. A is the area of just the one side. S is the surface area of the whole cube, and it's multiplied by 6. So again, in that table, if we go back, here we've got our 4. So 4 times 6 equals S. Back. And that would be 24. Okay? So we're just creating a formula here. This is a function. It's using one number, an input, to calculate another number, an output. And so we've done that with this first table. Let's try it again using a different formula. So here in this problem, we're looking to solve the rule. So we're finding the rule for this function, and then we use that rule to find the value of m. So let's look at what we've got here on our table. We've got L equals 5, 7, 10, 15. If we want to look for patterns, 5 and 7, the difference there is 2, 7 to 10 is 3, the difference from 10 to 15 is 5. It doesn't look like there's a pattern there. Well, let's look if there's a pattern here. 20 to something to 25 to 30. It looks like it's going up by 5 each time, right? No, because 20 to 25 to 30. So there's something in between 20 and 25. So we're not seeing a pattern by looking this way. Let's look and see if we see a pattern this way. 5 to 20. 5 times 4 is 20. So we could choose 7 times 4 would be 28. 10 times 4 would be 40. So that doesn't work either. Let's see, 5 plus 15 is 20. 7 plus 15 would be something. 10 plus 15 is 25. 15 plus 15 is 30. So now we know what the rule is. It's something plus 15. The something here would be m. So L equals m equals plus 15. Okay, so that's our function. So here we notice 20 is more than 15, we got to that part. The rule here to find m is add 15 to L. So to find m is when L is 7, we add 15 to 7, and we get 22. So the missing number is 22. Instead of the letter m at the top, we could have just written the rule. And that's what they've done here in the table is instead of m, they just said L plus 15. So m equals L plus 15. That's the function. Okay. Now, sometimes once we've solved it, we can graph it on a coordinate plane. we show the function table relates to the perimeter of a square. So here we have S for the length of the side and P for the perimeter of a square. And here we can see 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. We know that because 4 sides equals the perimeter in a square. So we already know the formula to solve the table, but now we can graph that. Now you'll see we're going the length of the side on one coordinate plane and the perimeter on another. They've gone 1, 2, 3, 4, 5, 6, and here they go 4, 8, 12, because those are the units we're dealing with. 1, 2, 3, 4, 4, 8, 12, 16. Now, is that a perfect representation on a number line? No, because 1 doesn't equal 4. But here we're representing it that way just to see the equivalent value. So now if we draw that out as a ray, it just shows a straight line. If we did it as, instead of 1, 2, 3, 4 like that, if we did this being 4, and then up here would be 8, then it's going to plot very differently. If we go 1, 4, 2, 8, you'll see that the angle is much steeper, but with the table that we have, we can just create an equivalent value on that table. And so I'm going to skip this one because I just explained that. So here we show the ray, that's what I just drew. Let's try this again. So now we find the missing number in this function table. Again, we're looking for patterns here. So 2, 3, 4, it looks like it's going up by 1 each time. 4, 7, we could guess that that would be a plus 3, but they already told us the function. The function is 3x minus 2. Well, if we already know that x equals 3x minus 2, then we can just plug in the number for x. So plug the 2 in here, and 3 times 2 is 6, minus 2 is 4. So that's why the answer here is 4. If we plug x into here as a 3, 3 times 3 is 9, minus 2 is 7. So that's pretty easy to figure out. Plug the 4 in. 3 times 4 is 12, minus 2 is 10. Bloop. Perfect. All right. So then we get 3 minus 4 is 10. Pretty easy to solve that one. The perimeter of an equilateral triangle. So here we're going to try to solve that. Now remember, equilateral triangle, that means every side is the same. Is a function of the length of its sides. So 1 equals 3 because they're exactly the same for the perimeter. So one side, S, equals 3, P for perimeter. Make a table for this function using lengths of 1, 2, 3, and 4. Then graph the ordered pair. So actually I don't need to draw this, I'll have it on the side. 1, 2, 3, 4. 1 equals 3. Remember, 3 sides equals the perimeter. So then we just do each number times by 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Now, to graph that out on a coordinate plane, we simply go 1, 2, 3, 4. And then here they're going 1, 2, 3, 4, 5. They're doing it in measurements of 5. So remember, we had 1 is 3. So 1 goes to 3. 2 to 6. 3 to 9, right? I'm going the wrong way. 3 to 9 and 4 to 12. So that's how we get it graphed out on a plane. So you just use that table to graph it out on a plane. And that's it. That's the lesson. It's new language, so it's a little complicated, but once you practice it and get used to doing it, it's really not very tricky. Here's a few practice sets, and then you can do your assignment.